So first of all, who are we? So we are the Center for Cellular Imaging at the University of Gothenburg. We are a national core facility that integrates both light and electron microscopy. We offer open access to all our equipment to researchers or companies as well within in Sweden or also abroad. And then depending from where you are from and you want to ask access to our equipment, then you might do this via the National Microscopy Infrastructure, or you might do this via the Euro-BioImaging and so on, right? So the idea is that we will help and support your research no matter where you're from. And then you are just always free to contact us. Now, what type of services we provide? Well, as I quickly mentioned, we have actually a broad range of services. At the Center for Cellular Imaging, we have light microscopes that go all the way from the wide field microscope and high content screening to confocal, multiphoton, super resolution microscopy, and also other equipment such as laser microdissection. At the same time, we also have scanning electron microscopes and transmission electron microscopes. And the other thing, of course, that we love when we have such, all of this equipment within the same house is that we like to use them at the same time within the same sample, right? So what we like to do is to do a lot of correlative workflows where we take the same sample and we move it between different types of equipment, and we try to benefit from this process. So basically that we can get specific signals that are only possible in one technique and then combine them with others. Now, in this sense, with all of this equipment and all of this different type of image data, then what is going to be very crucial, of course, is the image analysis and the data handling as well. So we can also support you with that. And then depending on your sample, depending on what type of projects you want, then the next question is who is going to help you, right? So we have a lot of equipment, but we also need a lot of very broad expertise. That's where my colleagues come into place. So as you will see at the bottom, this is the staff of the Center for Cellular Imaging. We are, each one of us specialized in a slightly different area of science. So that means that we also have a lot of complementary skills. So if you come to us, and we are going to, you are going to benefit also from that very diverse group of people. Now, the Center for Cellular Imaging has an open access policy. So we are basically a user-centric facility. That means that if you come with your project, what we are going to do is that we are going to train you in the operation of the microscopes in such a way that you become independent as soon as possible. And after that, you will have access to the microscopes potentially 24/7. This, of course, depends on the level of training and depends on the equipment. We are going to offer, of course, continuous support via all the projects. So from the beginning in consultation, training, and data processing. And here is where we also started to play a lot with the remote access, is that we are going to have different type of training methods where we are going to combine remote sessions with on-site sessions during the training. The purpose of this is manifold. Sometimes we might have users that are coming from different countries, and it's much more convenient, of course, to start the training process even before they arrive to us, so the visit can be shortened. Also, during the time, for example, of the pandemic, we had the case in which we could not all be present physically in the microscope at the same time. So there is many moments where this remote access and remote interaction is going to be very critical, and is going to help us to improve the efficiency and also improve the feeling of the satisfaction, basically, of the users when they come at the facility. In most cases, we use Microsoft Teams for remote interaction, but as you will be seeing later today from the use cases of my colleagues here, we also have a long, different arrays of tools to be able to interact with the users once they are at the microscope. Then how you set this up very much depends on your, sort of internal IT policies. In our case, our microscopes are in a special intranet, and they don't have free access to the internet. And the way in which we allow people to have access to that equipment is via proxy servers. And that way, we also have a lot of control over who can see what and when, and what level of access they might have to the different type of equipment. Also, we have a core management system that I pinpoint there on the right that allows us to integrate a lot of the booking and a lot of the, let's say, the handling of from the user perspective of how much am I booking the microscope, how much the service is going to cost. All of that is also taken care of via the web. Now, in terms of remote services that we provide, you could divide these in slightly different classes, I would guess, depending on how's the service provided. So in many cases, what we have is that, of course, we have remote and hybrid courses and demonstrations. And there we have tried several different models, from the fully remote to the fully on-site. And currently, we tend to use a hybrid model. This allows us to benefit, in many cases, from very interesting speakers that might not have the chance to travel, or perhaps we might be able to train groups that for example, that might be in a different country, and then we can help the students to get the information from the course or from the demo. Now, we also have remote support to on-site users, and by that, what I mean is that the user might be operating the microscope, they might have a problem on the machine, and then they will contact the staff via, for example, Microsoft Teams. They send a message to us saying that there is a problem in the equipment, and in many cases we can help them remotely, or if not, we just one of us of the staff that is present can walk to the microscope and help them physically. We also do a lot of acquisition guided by the feedback of a user. In this case, the staff is sitting at the microscope, and there's a user which remotely connects to us, and they are going to help us to find what is the most interesting area of the sample, what specifically they want to do, and so on. And this is extremely convenient at the beginning, for example, to do some sample testing before a visit from somebody that is abroad or doesn't live in the city. Then we actually have the actual remote instrument control, where the operator is going to be a user and it's going to be remotely. Here I put demo, but I don't think we'll have from my side, I will not have a chance to demo this, but I know that my colleagues will show some of this potential during the presentation. And another thing that also happens remotely, of course, is all the data management. So the idea is that once you have acquired your images at the facility, then how do you transfer your images from the microscope to the final data storage solution or the image analysis workstation? In the image analysis support, we have remote access to image analysis servers or workstations, and also consultation, etc. All right. So again, just a reminder, if at any point you want to ask a question, just let me know. One of the first things that you should try to set up very clearly for yourself to make life easier is your data management plan. And here, I think from our perspective, what was very important was to make sure that we had very clear how the data will be transferred between the different networks at the university, which equipment lives in which network, and which one of those require direct access by the users. Some of those networks might actually only require direct access by the staff, and so on. So this you have to sort of clear up carefully together with your IT services, right? So the idea here is that I'm showing a part of our data management plan. What you have is that the images are acquired at the CCI, as I mentioned, they live within their own network infrastructure, and then that data has to be transferred to different places depending on what we want to do with that. Let's say most of our users, if it's a relatively small project, they might just want to take the images with us and then directly transfer it to a special server that will work sort of like a Dropbox kind of thing, or Google Drive. So they can drop their files in that transfer server, and then they can go home and they can download the data. In some other cases where they want support for image analysis, they might move that data then to a workstation where they can have access either physically or remotely. Or if it is very demanding, they might not move it to a standard workstation, but they might move it to our processing server. In this case, we have a Hive, is a solution from Aquifer. And then we might move the data in there, and that also allows us to interact with the data and with the users directly on that server. Now, for the remote instrument control, the problem here is that there is no way to set this up that would be general. I think this very much depends on your equipment and the regulations of your own institution and so on. But here I just put a few general considerations that I think are quite important. So if you are going to set up a truly unsupervised remote instrument control, so the user is going to be alone handling the equipment, then the first thing that you have to take care of course, is the safety of the equipment. So you have to make sure that you put checks and balances in line. They could just be simply very, very careful training and information to the user, but also there could be like actual software running in the microscopes that don't allow the user to move or to do certain things in such a way that you try to handle the best you can any risk to the microscope. Also, you will have to do a lot of considerations about your IT infrastructure. Because you need to, in many cases, make sure that the communication speed and the data transfer between the different equipment and the servers and so on, it's fast enough that the user is not going to feel that there are any hiccups. Then, as I mentioned, the training procedure is going to be very important, and you will have to fine-tune it to a specifically remote instrument control. And in many cases, you do need to have that conversation of, is fully unsupervised remote control needed? In many cases, we have found that actually monitoring the experiments from the outside and then being able to just stop the equipment and move to the next sample, for example, it's one of the first things that most people will benefit from. This will allow you then to have more access to your equipment. I just then want to make sure to pinpoint that the remote access then allows you to democratize more the access to your resources, especially for researchers that are coming from other institutions or countries where, like they might not have this equipment. So we argue that actually we should start to invest in procedures in which we can prepare the samples, the biological samples at the source. But then these samples can be shipped to different imaging facilities, and then the staff can grant access to the different users at these facilities so they can image those samples, and then the project can move forward, and there could be an uncoupling between the preparation of the samples and then the actual observation of the samples. And right now, there's a lot of technology available that could allow you to do such things. Finally, one thing in which we are investing a lot of time is in what we call smart microscopy. The idea of smart microscopy is that basically we are going to start to integrate automated control of the machines together with image analysis to generate image acquisition pipelines that can take decisions on the fly. And of course, this type of, let's say, feedback microscopy is very much immune to remote access, because the idea here is that the user can have a very specific pipeline that has been designed for them. They can go to the microscope, they can ask the microscope to deploy this pipeline, and then these pipelines can take several days or hours, and then the user will be monitoring this experiment from home and then can make decisions on the fly if something goes wrong as well. Smart microscopy as a service is quite complicated because in many cases, this type of workflows have been defined for a very specific use case. And then what we believe is that core facilities such as the CCI can then take those methods and concepts and actually make them available to a broader research community. And then here we are very proud that this has also agreed on, let's say, the view of the research in Sweden, and we have got a research infrastructure fellow grant from the SSF that will help us to support this endeavor for the next 5 years. So with that, I think